Hey everyone, it's Mr. McDaniel again, and we are back with NTI Day 8. This is just a mixed practice with the Pythagorean theorem, but I'm going to kind of help you set up the problems just in case anybody has any questions. These first two, we're just finding the missing side length, and if you haven't done NTI Day 4, 5, 6, or 7, I would suggest having those finished before we try to tackle this assignment. So if you remember, the Pythagorean theorem is a squared plus b squared equals c squared. And then when you're trying to find the missing side length, all you have to do is substitute the values that you have in. Remember, a and b are the legs of the right triangle. So I'm going to make this missing side a. So that means this is a variable that I'm going to be solving for. So when I set this up, is we would have a squared plus 21 squared equals, I messed up, do that as 35 squared. Sorry, I went to write a C. So we would do that as a squared plus 21 squared equals 35 squared. And then we're going to have to solve for a. Now, if you're not sure how to do these, I would go back and watch the video that I attached to NTI Day 4. That'll show you how to solve for missing side lengths for one of the legs. On this one, we're trying to find the hypotenuse, which would be C. Remember, C is always the longest side of the right triangle. So when I go to set this up, I would normally have a squared plus b squared equals c squared. I have my a and b, so I'm going to do 16 squared plus 30 squared equals c squared, and then we would be trying to solve for this C variable. And again, if you're not sure how to solve those, go back and check the NTI Day 4 assignment. Okay, now on this next set, as we had some of these in the other assignment, is you're supposed to tell whether the three side lengths would make a right triangle. And what you're doing with these is you're going to substitute those in to the Pythagorean theorem. Now you'll notice in each of these, the side lengths are arranged from shortest to longest. So that means the first two are your legs and the third side is your hypotenuse. So what we're trying to see is 11 squared plus 60 squared equal to 61 squared. Okay, so then to do that is we're going to have to plug that into our calculator. Let me bring this up here real quick. And so if we plug these three values in and it makes the Pythagorean theorem true, then that means that it would, in fact, make a right triangle. Okay, here we go. So our three values were 11, 60, and 61. So here we go. If we do 11 squared plus 60 squared, that is equal to 3,721. I'm going to go ahead and jot that down so I don't forget that number. I'm going to write 3,721. Now, if 61 squared is equal to that number, then that means it makes a right triangle. So let's see. We do 61 and then press our x squared key over here. It is equal to 3,721, so that would be a yes. Okay, if you plug your values in and the left side of the equation is not equal to the right side, it's not a right triangle. Every single right triangle will make the Pythagorean theorem true. Okay, then on this last part is you're supposed to find the distance between 2 points. Now these are diagonal distances on a grid. Now if you remember, we can set this up as right triangles. So say we want to find the distance between point A and point B. So what we're going to do is I'm going to go ahead and draw a line to connect those two. Got my trusty straight edge. Okay, now remember we can draw legs so it makes a right triangle. So we now have a right triangle that has legs of 3 and 1, 2, 3, 4, 5, 6. Okay, so that means that in this case that 3 squared plus 6 squared, I'm going to write this here, 3 squared plus 6 squared would be equal to c squared. So 3 squared is 9, because 3 times 3 is 9. 6 squared is 36, would be equal to c squared. I can go ahead and add 9 plus 36, and that gives me 45. It's equal to c squared, so that means that c has to be equal to the square root of 45. Now that is unfortunately not going to be a perfect square, because I know there's no whole number that you can multiply by itself to get 45. Okay, so we're going to use our calculator again, as we're going to press 45. Then we have to use the square root key. Remember, it's this little key right there that has a square root sign and a little 2 by it. It's going to be about 6.7. That's 6.70. That 0 is not going to round that digit up, so we can just round it to the nearest tenth, and so we can just leave that as 6.7. And then with the others, same thing, as you are looking at a diagonal distance, like from B to C is going to be a diagonal, and then from A to C is a diagonal, and all you need to do is just put your legs in that you have, draw a right triangle, and that's that. So that's kind of a quick recap on how to do NTI Day 8. Message me with any questions you might have. I'm here for you. Good luck. Hang in there. Bye.